This video is about spectral resolution. As you can see here, we have a single band image, black and white, panchromatic, but for the purposes of this we'll call it monospectral. It's broken up into a number of different regions. It's got pinewood, grassland, some red sand and silty water. And each of these has a reflectance index here. This would be classed as their spectral signature. So we're looking at the amount of reflectance coming from the sun and the wavelength on which it occurs. Now, as it's a single band, we're looking at one broad capture across a broad wavelength, and we have this spectral response. So, it's quite easy to discriminate the red sandpit here because it reflects very highly, but the other three have pretty similar reflectance percentages. Now when we move into the multispectral, and here we're looking at 4 bands from Landsat, we can see that we actually have a layer stack of multiple different single band images, and you notice here that we now have a spectral curve where it's easier to discriminate things, so we can do some band algorithms and band mathematics to start to discriminate some more of these features more effectively. You'll also notice that this spectral curve is starting to become a little bit more unique. Here we couldn't understand, or differentiate rather, what was going on with these 3 different types. We now see that we're getting more variation and we can find different ways to discriminate between them, particularly looking at, say, ratioing between band 4 and band 3, for example, and that would be your red edge shift, looking at vegetation. Now if we pull into hyperspectral, and here we're looking at avarice, which has many hundreds of bands, you're looking at a very complex spectral signature, which allows you to discriminate quite finely about what the object under study actually is. You have a huge cube of information, and here you have an excess data problem. You've got lots and lots of data across a large spectral wavelength, which allows you to discriminate in quite a refined way about what's going on within that scene. In addition, you can get lab-based spectral signature curves, which you can compare against what you're getting in the field and define elements down to either specific vegetation species or specific types of geology.